Hello friends, my name is Shashank and welcome back to my channel Shashank Tutorials. How are you all? So today we will be discussing about the second part of spherical mirrors, that is the principal focus. Now in the previous video we have seen different types of terminologies, that is the pole, the center of curvature, the principal axis and the radius of curvature. Now in today's video we will discuss about principal focus. Now what basically is principal focus? This plays a very important role in both reflection and refraction of curved surfaces. Now in front of you I'm having a spherical mirror. In the previous video I think you got a clear cut clarity about different types of spherical mirrors. If the reflecting side is in the inside part, like in the cave part, then it is concave. When it is on the outside part, if the light rays are reflecting outside, then it is convex. Simple. Yeah. Now principal focus is very important topic. Please. Now this is pole and this is center of curvature. Okay, I'm thinking this is the center of curvature. Now any object which is, now this concept is very important. Any object when placed at an infinity point to the mirror, means the object is at infinity distance from the mirror, then the light rays from the object come parallel to the principal axis. Very important. When the objects are placed at infinite distances from the mirror, then I'm sorry, object is placed at infinite distance from the mirror, then the rays coming from the object are parallel to the principal axis. Yeah. Now here, let us consider an object which is placed at infinity. Now we are going to draw a parallel line. Okay. So there are some light rays coming from the infinity. Yes. Another. I'm considering 4 rays for now. Yeah, infinite rays may be coming. Now, in the previous video, we have discussed about the normal for spherical mirrors, that is something like this from the center of curvature. Now, draw normals to the point of interaction. Yeah, and here too. Yeah, and then same what we were doing in the case of plane mirrors, we were doing the reflected ray like this, that is this angle will be equal to this angle. Yeah, I'm sorry. Yeah, new technology, what to do. Yeah, now when we will be applying the laws of reflection here. Now this angle will be equal to this angle, so it will be coming like this. So this will be coming like this, this will be coming like this. Yeah, this will be coming like this. So I'm trying to draw neatly, becoming like this. So as you can see, these are different rays which came from infinity, which came from an object which was placed at infinity, and they all came and met at this one unique point. So this is a unique point. Now this point is called focus. This point is called focus. Now let me get rid of all these extra lines. I'm sorry. Yeah. Okay. So I think you understood the concept of normals. So when these all come together, they are meeting at a unique point, that is called the focus. Now understand the concept here. All the rays are converging at one point. So for this terminology, when the rays are coming and converging, so this is called converging. Rays are coming and meeting at one point, and from one point, if the rays are emerging from this point, the rays are emerging. So this kind of lines or this kind of rays are called diverging rays. Okay, so these are converging at one point. So this point is called focus, the principal focus. And there is a parallel concept for principle of focus. We will be discussing about this focal plane, the focal plane in refraction, the second chapter. Okay, so the focal plane. So when I draw a unique, means if I draw a plane, an imaginary plane to the focus, then that is called the focal plane. Now we discussed about in concave mirror. So this is for concave. Let me tell you the definition of concave. In a concave principal focus, that is the rays coming parallel to the principal axis after reflection from the concave mirror. They all converge at one point. That point is the focal point. Okay, so that is the focus. That's the principal focus. Now, for example, let us take a concave lens, a convex lens. Now, I'm having another setup here where this is a convex mirror. Now, what happens in the case of convex mirror? The outer side is outer side is reflecting. So this side is reflecting, and the inner side is silvered. What happens in this case? The same. The object is placed at infinity, and the rays come parallel to the principal axis, isn't it? Yeah. The rays always come parallel to the principal axis. To make your diagrams neat, I give you this suggestion which my teacher gave me. That is, the number of rays in this upper portion should be equal to the number of rays in this down portion. So when we take something like that, the rays will be, the diagram will be good. Okay. Now, these rays are emerging from an infinity object. What happens in the case of convex mirror? Now, what happens? The same. The normal is emerging from the center of curvature. Yeah. See? So, this will be the normal. This is the normal. Now, when we draw normals like this, what happens? These rays will diverge. Okay. So, can I erase the normals? I think you got the normal concept very clear. Now, the normal came like this. So, the refracting ray will be like this. Okay. It is going and meeting the next diagram. Now, for now. Okay. I hope you can understand the concept very well. So these are the reflecting rays with respect to normal. So here also the laws of reflection are valid. That is, the angle of incidence is equal to angle of reflection. Now what you are going to do to make the focus, you are going to trace back all these reflected rays. Okay. According to my diagram, they are meeting at this point. So this point is my principal focus. So you have to draw a very neat diagram normally. So this point will be the principal focus. And even just we will be discussing about this concept also very well in the next chapter, next topics. That is the distance from, let this be pole, this be focus, and this be the center of curvature. This distance and this distance should be same. Okay, so you draw your diagram like this and you try to converge the rays in such a way. Okay, practically this happens generally. Okay, this distance will be equal to the focal length. focal length we will discuss now. Now this is for convex mirror. I think you are very clear about concave mirror and convex mirror. Now let's discuss about focal length. We discussed about focal plane. Yes. We discussed about focus, how focus is formed in concave mirror and convex mirror. Now we will discuss about focal length also. Yeah. Now what is focal length? Okay. Let me draw it on scale. So you are going to take a curve like this. That will be your mirror. So uh, silvered this side, outer side. This is the pole. This is the focus. This is the center of curvature. Okay. This is the pole, this is the focus, and this is the center of curvature. Now, the distance from pole. So let me do this. This distance from pole to the focal point. So the distance of from pole to the focal point, this distance is represented by small f. This is called the focal length. Okay. This is called the focal length. I hope you are very clear about the focal length. Focal length is the distance of the distance between the pole and the focus of the mirror. So this distance is called focal length, and this is a very famous relation and very important relation also. R is equal to 2f. R equals to f. What was R? R was radius of curvature. That is the distance from the pole to the center of curvature. So this is R. R is always 2 times of f. Means this distance will also be equal to f. R is equal to 12. So in this video we have discussed about focal length very clearly, and from the next video we will discuss about ray diagrams, the rules to draw ray diagrams. So that's all for today. Like, share and subscribe. Do not forget to click on the bell icon to get instant notification. Check out my shorts channel also. Link in the description. Thank you and have a nice day.